Hello everybody, welcome back to another video with Mr. Coder. And in this video, I'm going to show you how to do problem F, Rudolf and Imbalance. And this is from Codeforces Round 933, Division 3. So basically, Rudolf has a set of n problems, and they're given to you in sorted order with all different complexities. And he isn't satisfied with the balance, so he wants to add at most one problem to fix it. And he came up with m models of problems and k functions. The complexity of the ith model is d of I, and complexity of jth model is f of j. So, and to create a problem, he selects values I and j, and you can combine them. And the new problem has a complexity of d of I plus f of j. And to determine the imbalance of the set, you sort them all, and then you find the largest gap, or the largest a of I minus 1. And what is the minimum value of imbalance that Rudolf can have by adding at most one problem? And that has to be created using the rules. And then a key thing to note is that it says at most one problem. So you can leave it as it is. So basically, if we look at this problem, 5, 10, 15, 20, 26, and there are these ways of models and functions. So basically, there's a gap of 5, 5, 5, and 6. So obviously you want to get this gap first. So you try looking for a gap that fits, and of course you can do you would be able to do like 16 and 8, and then that would lead to be 24, which splits this gap. And then the next largest gap would be this 5. But of course, if the gap's too large, it still might be one of these sub-gaps that happen. So yeah, that's basically the problem. So then it would still be 5 it would still be 5 since he split this one up, and then there's still this 5 here. So this is basically how I did it. I got the input, and then I kept a multiset of all the different gap differences, and I also kept track of which one was the maximum and what had the low and high. So then I can use that later of the low and high value. So in this case, it would be 26 and 20. And then now I sorted the D and F, and I got the goal. I got like what the target was. And then the key thing is that because M and K are less than or equal to 2 times 10 to the 5th, which means that if you do 2 for loops of MK and then you tried all of them, that would get TLE. So you'd have to use some binary search, which I did. I went through every number in the models, and then I checked which one would fit the best in the functions, which I just use a simple lower bound. And then since I didn't want to check here, I just did the current one and one behind for the problem value. And then I just did the lower bound of all the, like, I created a multi-set of all of them, like all the new problem values that would work well, and I got the lower bound. And then since lower bound gets the next greater than or equal to element, so then I also have to check less than, because if the greater than was further away than the less than, I had to check that. So yeah, I just checked which one was the best, which one was the closest to the goal. And then that basically, I got rid of the maximum, and then I replaced them with the new gaps. And then I checked for which one was the maximum. And of course, if the maximum was now, like, if it was now greater, then I would have to go back to the original maximum or ms.begin. or it will actually be max, and the ms.begin would be the new gap that would be found. And it's just finding the minimum of those between 0 and 1. So yeah, that's basically how you do this problem. So in summary, you basically have to just get all the gaps and notice that it's always optimal to try filling in the largest gap. And if you have two largest gaps, then it's of course impossible. So you just run it through, and you realize that the gap's still the same. So that's basically the answer. And another key thing is that to find the best values, you can't just loop through all of the m and then k, because that would lead to time limit exceeded. So you'd have to binary search it using, and for simplicity, I just use the lower bound functions. And so yeah, that's basically how you do this problem. Thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next video. Bye.